This video is going to go over two examples of stoichiometry, and then there'll be a second video that will go over two other examples. So stoichiometry is just a fancy way basically to show mole-mole relationships. It's how we switch from one compound to a different compound when we're dealing with chemical formulas. So I've got an example here of what we've been dealing with writing of formulas. So you can see on that first one, we want to write a balanced equation, figure out what it's going to form, figure out if it's redox, and write a balanced equation. So I'm just going to write the answers in. If you want to pause the video and see if you get this right, kind of, check yourself. Pause the video right now and then start the video again and see if you got it right. And then we are going to pick up the video on letter E. So that way, if you're not getting it right, you know you should start asking questions in lecture. All right, check your answers. How did you do? Hopefully you are seeing it is a double replacement, so it's double replacement, so it's not a redox, and it would need a coefficient of 2 in front of your silver nitrate and a 2 in front of your silver chloride. All right, so as we begin stoichiometry, so this is similar to what we were doing with the mole. The difference is we're going to start to see that our label is going to change. So I'm going to underline what I'm starting with. And you see the word excess. So for now, we're just going to do plain stoichiometry. We are going to learn limited reagents, but excess just means you've got more than enough of it. It would just be to help you write that balanced equation. So for now, I'm just going to have you mark through that and ignore. If you have excess of something, it means you've got plenty of it. Okay, so that's what I'm going to start with. And notice this is what I'm looking for you to find. And do you notice that it's a different compound altogether? That's what makes it stoichiometry. So I'm going to come over here, and you don't have to do this, but it does help, especially with limited reagents. I'm going to write what I call the given and then the wanted. And this is going to help you just kind of identify what should you be starting with and where should you be ending. So what you're starting with is your number, the label, which is mole. I'm sorry, the unit and the label, and it is AgNO3. And we are trying to figure out moles, so same unit, but we're switching it to MgNO3 2. Okay? So we're saying if we have this many moles of this, how many moles of that would be formed? And based on what we've got going on here, can you see for every 2 silver nitrates, we're going to get 1 magnesium nitrate. So the ratio is a 2 to 1. And so maybe some of you can already see as half, but we're going to learn to do the stoichiometric table for that. So I'm going to begin with, and I do like colors for this. So I know some of you are not a fan of colors, but I'm going to use, well, might as well stay with that purple. I'm going to purple and red. We'll start with red. I'm going to start here with my moles of AgNO3. And I'm going to bring down moles of AgNO3. Okay, so this is very similar. So before I said anytime you have the word mole, you're always going to put a 1 next to it until we do stoichiometry. So we're doing stoichiometry. So when I bring that mole down in stoichiometry, it may not be a 1. It might be a 1, but it may not be a 1. And what makes this stoichiometry is the fact that we are seeing that these labels are different here. I'm starting with 1 compound, and I'm looking for something else from this balanced equation. And the way I switch these labels up is with what's known as the mole-mole ratio. So because I'm wanting to switch the label to MgNO3 2, the unit here has to be mole. This is called the mole-mole ratio, and it's how I switch the labels from one compound to another. Now, if you look and see what's canceling out here, that's canceling out, and I've got what I'm looking for is moles, which is good. Again, this is mole-mole ratio. Where these numbers come from is from our balanced equation. So if you watch the video on the terminology or the vocabulary, I said that coefficients are the large number to the left, but they're also called the mole-mole ratio. So if you'll notice, in front of AgNO3 there is a 2. But in front of the magnesium is an understood 1. So for every 2 of these, I'm getting 1 of those. So for my mole-mole ratio, this is going to be a 2, and that's going to be a 1. Now I'm going to stop this one because I've gotten to what I want in this top right corner. So now I'm just going to multiply and divide, or just take that divided by that because those are 1s. And my unit here is going to be moles magnesium nitrate. And I'm just dividing. Now your calculator just gives you that. Now beginning zeros are not significant, so I want 3 significant digits, so I actually have to go 2 more decimal places past that to get the correct answer. Alright, that's called a mole-mole problem. I don't care that you know this type here, but starting with the mole of one thing and going to the mole of the other. Alright, let's look at our second example for this video. Again, there's an example of the equation, so stop the video, see if you can get it right. Start the video again, see if you got it right. Alright, check your answer and see. It should be making sodium chloride. Now I went ahead and showed you metal gas in here because on the active app they're going to give you states of matter. They would also have told you this made a solid, and so you're going to need to be putting those states of matter when you write a balanced equation for the active app. So I wanted to go ahead and put them in there. You won't need to do that for me on their tests, etc., but I just wanted to show. So this S, G, and S you won't need for this unit 3. We're going to be doing something in unit 4 that you're going to use that for. But hopefully you did okay on that. So I have my given and wanted here. So again, I'm starting out with moles, and I'm going to mark through that excess words, and this time I'm looking for grams of sodium chloride. So I'm starting with this, and I'm looking for grams of NaCl. So we're doing stoichiometry because we're starting with one thing and going to something different. So we're going to start out with 0.500 moles of sodium. I'm going to bring moles of sodium down. The minute mole of sodium is in this bottom right corner, you can switch the label to NaCl, but you may not switch it to grams because the mole of sodium doesn't equal the grams of sodium chloride. So the only way this labeling, and I'm stressing different colors here, the only way this labeling different colors that I've got going, it has to be what's called the mole-mole ratio. Every stoichiometry problem has this. Even if the ratio is 1 to 1, it still needs this right here. Okay, where are these numbers coming from? Well, they're coming from the balanced equation. In front of NaCl there is a 2. In front of Na there is a 2. So let me stay red with that. Can you see canceling out? So if I stop this, I'm going to have moles of sodium chloride, but that's not what I'm looking for. So I'm going to continue this one down. Do it in purple since I've switched over to purple. And then, so this I'm going to bring mole of NaCl. So notice this is still going to say NaCl, which is the labeling that I want. From mole of NaCl, I can go to grams of NaCl. And anytime mole and gram are together, mole and gram, it would be 1 mole, mole and gram, 1 mole, and this would be the molar mass off the periodic table. So 1 sodium and 1 chlorine off the periodic table would be 58.44. Remember, we don't use Avogadro's constant with grams, we use molar mass. And so I'm using the molar mass. So right here is the only time you're using the ratio is when it says mole over mole. So now I'm going to just multiply across the top and divide by your bottom, and you would end up with 29.2 grams of NaCl. Alright, that's the first 2 examples of stoichiometry. I'll see you on the next video for the next 2 examples.